length, mass, time, model building, conversion of units, orders of magnitude, and significant figures. Today we're going to look at Chapter 1 of the Serway and Jewett Physics for Scientists and Engineers, Physics and Measurement. So here's my summary of the chapter. Length, mass, and time are important. They got SI units, length is in meters, time is in seconds, mass is in kilograms. These are the building blocks of physics. You're going to see these things very often, so you should know their definitions, their units, and common things that they are used for. An example, density is mass over volume. Volume is length cubed. Area is length squared. Mass is related to weight. Length over time, velocity. Second section, model building. Models are important. You're going to see in the next video in chapter 2, we create two models. The model of the particle under constant velocity and the model of the particle under constant acceleration. In physics, it is very important to use models. We will see, because models are used in the strategy for solving problems that the authors show us in chapter 2, again in the next video. Next, dimensional analysis. You got units for everything, units cancel out, and equalities in equations tell you that both sides of the equation, the left and the right, should have equal units. You can use this to help you solve problems, make sure things got correct values so that you're not doing any kind of algebra error. And you can also use this to cancel and figure units out from different equations. Converting units is important. Make sure you know how many units is equal to another unit. An example is how many Celsius degrees equal how many Fahrenheit degrees or Kelvin, how many pounds equal how many kilograms, how many miles equal how many kilometers, and so on and so forth. Converting between units is good. Here's an example. You can try to estimate the number of breaths someone is going to take in an average human lifetime. Very quickly, how to solve this problem. How many years does an average human live? 80 years, 100 years, 50 years? Pick a number. How many days comprise that number of years? How many days equal 1 year? Use that, use some dimensional analysis, then you'll find out how many days comprise a human lifetime of about 80 years. How many hours? How many minutes? And then approximate that a human breathes maybe once a minute, maybe 10 times a minute if they're exercising. Multiply that, cancel the units, and then you will get number of breaths. So the unit breath at the top per lifetime. Here's the solution that I did on a little napkin. Check it out, see if you guys agree with me. And finally, significant figures. Significant figures, check out this video by Professor Dave Explains. You're going to be boolin'. And that is chapter 1. If you guys want to see my notes, here it is, screenshots from the book. Thank you guys, Serway and Jewett, and all of you fellows. You can read some of my notes here. I'm not going to go through this. I'm just going to show you guys. A lot of it is taken from the book. And if you're interested in my notes, or if you're interested in like looking at this stuff more in depth, let me know. But this is a quick summary video. And my notes sometimes are not complete. Guesstimate. So, I don't know, order of magnitude. How much is a grain of rice compared to a building? Definitely several orders of magnitude in mass and length and size and stuff like this. Orders of magnitude, let me know if you got questions about this. Significant figures, watch the Professor Dave Explains video. In the next video, we're going to check out two-dimensional motion. Thank you guys for watching. If you want to do some specific problems related to the first chapter, let me know, put a comment, and I will do a problem for you guys. But if you have no questions, we're going to keep moving to chapter 2. Thank you guys for watching. Peace out.